point estimate and interval estimate. We want to do point estimate and interval estimate for population parameters such as mean, standard deviation, and proportion. In this exercise, we want to estimate mean. So let's read the exercise. In order to increase the number of customers, a fast food restaurant regularly monitors its times of services to ensure that its speed of service is improving in time. A sample of 20 times of service has been taken on a randomly selected day and is shown in this table. In the part A, we want to estimate the average service time. It means that we want to give the point estimate, but point estimate for average of the population is going to be the average for the sample. So first of all, by the given information, we have the sample size to be 20. However, if it is not given here, we can use count function and see how many items are in the sample. Point estimate for average is the average of the sample. So we can write average and select the data in the sample. 84 is the average for the sample, and we say that this can be a point estimate for the population mean. To continue with interval estimate, we need to find the standard deviation, standard error, maximum error, and finally give a lower limit and upper limit for the interval estimate. First of all, standard deviation. If it is given, so it's going to be different. If it is not given, we are going to find from sample. Based on the sample size, if the sample size is less than 100, then we will say that the sample size is small, and based on that, we will determine the z-value or t-value, which one should be used. Since sample size is small and sigma is not known until part A, then we will need the t-value to determine the maximum error. So t-value is selected here. Standard deviation is not given in part A. We need to find based on the sample. So it is standard deviation from sample, and we select the sample. Standard error is going to be standard deviation divided by root n, or SQRT of sample size n. Significance level is given. This is related to part C. So we determine the standard error. So standard deviation we found from sample, and standard error is standard deviation divided by root n. Now for confidence level, we can see the confidence level here, 95%, 0.95. Significance level is 1 minus pi, or 1 minus confidence level, which is 5%. And since we want to use t-value, then here we have the probability alpha there. And to find t-value, we will write equal t dot inv, inverse function for t-distribution, and 1 minus alpha over 2 with degree of freedom n minus 1. So t-value is 2.0930, and now maximum error will be equal to t-value or z-value, depending on the given information, multiplied by standard error. So step by step. First, we find standard deviation. Standard deviation divided by root n is standard error. The standard error multiplied by z-value or t-value is the maximum error. Now for lower limit and upper limit, we find the lower limit by point estimate minus maximum error, and for upper limit, it is point estimate plus maximum error. Now, by 95% confidence, we can say that the average or the mean for the population is between 74.38 and 93.61. In part D, we have extra information and we want to use the same confidence or with the same confidence level, but with extra information that from past experience, we know that standard deviation of the population is now, it is 15. Now, in this case, standard deviation is 15. This is not S, this is sigma. So in the previous case, it was S, standard deviation for the sample, but this is sigma, standard deviation for population. So standard error will be similar, but this time standard deviation divided by root n, and confidence level the same, significance level 1 minus confidence level. Now this time, since sigma is known, we can use z value. So t value is for the case that sigma is unknown, is small. Otherwise, for estimating mean, we are going to use z value. Now this time we have z value. For z value, we have norm.s, standard normal, dot inverse, and 1 minus alpha over 2. Maximum error, standard error multiplied by z value or t value, in this case z value. Lower limit for interval estimate for mean is the mean for sample minus maximum error, and the other one mean for sample plus maximum error. So we can see that this time the interval is a little bit different, or it is more precise. In the previous one we had from 74 to 93. Now we know that it is between 77 and 90. So by having extra information related to standard deviation of the population, we have another solution. Finding confidence interval for mean and standard deviation, and also determining the relation between new sample size to have the maximum error equal to 1.5. A machine feeds cans of 1000 grams. During quality control, a sample of 9 items resulted in the measurements in this table. We assume that it follows a normal distribution. Part A, find the point estimate of the mean. Sample size is given 9. Point estimate for mean is the average for sample, which is 999 grams. Part B, we want to give the standard error for the mean. So standard error, we need to find the standard deviation first. Standard deviation for the sample, standard deviation dot s, which is 3.64, and standard error is standard deviation divided by root n. Now to continue for confidence interval, we need the confidence level. So we want to give the interval estimate with confidence 95%. Confidence level is 95%. Significance level 1 minus confidence level. Since the sample size is small and sigma is unknown, we need t-value. We have t dot inverse 1 minus alpha over 2. And degree of freedom n minus 1. Maximum error, standard error multiplied by t-value. And finally, lower limit and upper limit for mean, we have point estimate minus standard maximum error, and point estimate plus maximum error. By 95% confidence, we can say that the average feeling in the population is between these two values, lower limit and upper limit. Maximum error is given to be 1.5, and we want to find the sample size to have maximum error less than or equal to this 1.5. The relation between the maximum error and n, or sample size, is here. We know that to find sample size maximum error, we need the sample size. And we are going to use z value only, not t value, since in t value we have another n in the degree of freedom, and we cannot solve this equation for n. Now, we are finding z 1 minus alpha over 2 first. Z means norm dot s dot inv 1 minus alpha over 2. Alpha is the same. Now n prime is going to be standard deviation multiplied by z value divided by maximum error, and then the whole parenthesis squared. So n prime, which is going to be an integer, should be at least this value, greater than or equal to standard deviation multiplied by z value divided by the given maximum error, and whole parenthesis square. So we found 22.6. We should round it up, which is 23. So we need at least 23 for the sample size to have maximum error less than or equal to 1.5. And finally, we want to give confidence interval for standard deviation. So what's the standard deviation for the sample, which is the point estimate? We already found it. It's here. I can copy from there. Degree of freedom, because we have chi-squared, I need degree of freedom, which is going to be n minus 1. Confidence level 90%. In this part it is different, 90%, and significance level 1 minus that, which is 10%. Now, to find the lower limit and upper limit for confidence interval for S, standard deviation, we need chi-squared alpha over 2, chi-squared 1 minus alpha over 2, and in this two lower limit and upper limit, we can see that they are, all terms are similar. In denominator, just we have two chi-squareds. And for sure, the largest one should appear in the lower limit. So first we find chi-squared alpha over 2, which is the smallest number between chi-squared alpha over 2 and chi-squared 1 minus alpha over 2. Chi-square inverse alpha over 2, degree of freedom n minus 1, or I already found it here. Another chi-squared, but this time 1 minus alpha over 2, and the same degree of freedom. Now we put these two values in denominator. I need one SQRT at the beginning, n minus 1, which is exactly that degree of freedom I already calculated here, multiplied by s squared. This is s, and that one is squared, divided by chi squared. This is the lower limit. I need 1 minus alpha over 2, which is the largest number. and all term under the radical sign. And for the other one, again, sqrt, second root, n minus 1, or the degree of freedom, multiplied by s squared, divided by chi squared alpha over 2. Now, by 90% confidence level, we can say that the standard deviation of the population is between 2.6 and 6.2, and the unit is in grams. This time we want to give the interval estimate for proportion. The sample is given, and we know that if we want to do interval estimate for proportion, we need at least 100 sample size, or the sample size must be large, and we consider greater than or equal to as large sample size. So what is the sample size? The exercise says that in every half an hour, samples of 40 elements were taken. So we have this many times 40 elements as sample taken, so we need to multiply the number of times that we are sampling by 40. So here we have equal, this is the sample size. Now let's write the count function somewhere else. Still I want to do the count separately and then multiply it by 40 here, equal 40 times that value. We have 480 as sample size, which is large enough. K, the number of, in this case we are looking for number of defectives, and here we can see that the total is there. If it is not there, we can just find the total by a sum function. So K, the number of defectives inside this 480 element, is 42, and the proportion for the defectives in the sample is 42 out of 480, almost 8.75%. Now this is the point estimate for the proportion of the defective elements. Now we continue by confidence interval. So in this case, we have the confidence level 98%, significance level 1 minus that. And we know that for proportion always we use z-value, and here we have norm.s. .inv 1 minus alpha over 2. Now for maximum error, I need the standard error first. Standard error for proportion is sqrt p times q, but q is 1 minus p, so I can write again 1 minus the same value, divided by n. So this is the standard error. Now I need to multiply by z-value to get the maximum error. So maximum error is the standard error multiplied by z-value. And finally, lower limit and upper limit, point estimate minus maximum error, and point estimate plus maximum error. So in this exercise, the population size is given, and since it is not infinite, it is 780, then we may need the correction factor. And the correction factor depends on the sample size. If the sample size over population size is greater than 0.05 or greater than 5%, then we need that correction factor. So sample size is given, we have a sample of 100. Sample size is 100. Out of this 100, we have 26, in this case, unpaid balances. And we want to find the proportion of unpaid balances for the population. For the sample, we have 26 out of 100. Then proportion for the sample, which is point estimate for the proportion of the population, is k over n. And standard error is going to be this ratio, pq over n, but it should be multiplied by the correction factor, n divided by n, lowercase, uppercase, sample size divided by population size. So it is greater than 5%, it is almost 13%, then we need to multiply by correction factor. So SP is SQRT P times Q, which is 1 minus P, divided by N, so let me put this one in another parenthesis, and multiply whole thing by correction factor. Correction factor is root 1 minus n over n, but here for SP it comes inside the radical sign, we don't need another radical. So 1 minus n over n, n divided by n. However, we have that n over n there. I can just click on that, or let me select the same thing, n over n. One more time, SQRT P times 1 minus P or Q divided by N. Here by mistake I have typed N, so it is sample size, it is this value, D9 or 100, multiplied by 1 minus N over N. So it is 0.04. Confidence level is mentioned to be 90%. Significance level 1 minus that, and proportion always a z-value, then it is norm dot s dot env 1 minus alpha over 2. So this is 1.64. Maximum error, standard error multiplied by z-value, and lower limit, upper limit, the point estimate minus maximum error, point estimate plus maximum error. Now let's write them in percentage. We can say that it is this one multiplied by 100, this percentage, 19.26%. So if you want to answer the second part of the exercise, at least how many customers have unpaid balances, so the proportion of the people who have unpaid balances is between 19% and 32%. Now I need to multiply this lower limit by the population size to give the number of people. So here we have n, the population size. We know that at least this many, 19.26% of the population, multiplied by this percentage, or it's better to multiply by this one, which is already in the percentage. So out of 780, 151 customers have unpaid balances.